So in this problem, we need to find out the condition for which these 3 points become collinear. So let us begin. Now we know that if we have 3 points with coordinates x1, y1, x2, y2 and x3, y3, then the condition of collinearity will be met if this particular expression goes to 0. So we'll use this particular expression here. So let us begin. Now what we have here are 3 points. So we have the point A with coordinate a comma, a squared. B has the coordinate b comma, b squared, and C has the coordinate c comma, c squared. Now let's suppose that A is equivalent to x1, y1, B is x2, y2, and C corresponds to x3, y3. This is going to help us easily obtain the left hand side of the expression. Now what we have, the absolute value, we need x1. So x1 corresponds to A. So this will be multiplied to y2 minus y1. So that's b squared minus c squared. Added to x2. So x2 is b. So we have b multiplied to y3 minus y1. So that's c squared minus a squared. Plus x3. So x3 corresponds to c multiplied to y1 minus y2. So that's simply a squared minus b squared. Fine. So let's open up the expression. So we have ab squared minus ac squared added to bc squared minus a squared b plus a squared c minus b squared c. Right. Now we're going to combine few of the terms. So we are going to combine a b squared with, let's say we combine with negative a squared b. So that's going to be one single term. So this is taken care of. Then we take bc squared and we are going to combine it with negative ac squared. And then we're going to combine the remaining two terms, which is a squared c minus b squared c. Fine. Now, how do we combine it? But combining this means we are going to take a common factor. So if we take negative ab as the common factor, then this is going to be simply a minus b. Then here we're going to take negative c squared as the common factor. So this will get multiplied to a minus b. And then from the third term, we're going to take c as the common factor. And this will get multiplied to a squared minus b squared, but that's the difference of squares, which will be simply a minus b times a plus b. Fine. Further simplification, we'll now take a minus b as the common factor from the three terms. So we have a minus b, so multiplied to it will be negative ab minus c squared. Now we have c multiplied to a plus b, so that's positive ca plus cb. Fine. So we will now work with the term negative ab squared minus c squared plus ca minus cb. So we have absolute value of a minus b. So this will be multiplied to, so if we take ca minus ab as the common factor, so here we'll take a as the common factor. So negative a as the common factor. So negative a will be multiplied with b minus c. Then we're going to combine negative c squared with positive cp. Here we're going to take plus c as the common factor. So this will get multiplied to b minus c. Fine. So now we have absolute value of a minus b multiplied to, so we're going to take b minus c as the common factor. And then we are left with negative a plus c, which is nothing but c minus a. So here we're getting the expression, the absolute value of a minus b times b minus c times c minus a. And then we have to show the find out the condition for which these 3 points are collinear in nature. We know that they must be equals to 0 if they are collinear. So this is going to be equals to 0 in a equals to b, a equals to c. If this criterion is met, then we can say that the points a comma a squared, b comma b squared, and the third point c comma c squared, these 3 points are going to be collinear in nature.